The first slide will be the answers for the warm-up. So please, before you check the slide, do the warm-up questions on your handout. In today's lesson, we are going to learn how to find the sum of infinite geometric series. And the only vocabulary word for today is the partial sum. The sum of the first n terms of an infinite series. We are going to consider the infinite geometric series of a half, a fourth, an eighth, a 16th, and 1/32 or 1/32. And then we are going to graph the partial sums for the sum of the first term, sum of the first two terms, the sum of the first three terms, four terms, and so on. And then we are going to look at the graph to decide what happens as n increases, what happens to the sum as n increases. So here we are going to say how many terms, number of terms added. And then here we are going to have the partial sum for those terms. So if I add just one term, then the sum is just going to be 1/2. If I'm adding two terms, it's 1/2 plus 1/4. Since the common denominator is 4, so 2/4 plus 1/4 is going to give us 3/4. If I'm adding up three terms, that's going to be the sum of 1/2 plus 1/4 plus 1/8. And I already know the sum of the first two is 3/4. I'm going to add 1/8 to this. So this is going to be 6/8 plus 1/8. So the answer is going to be 7/8. Then if I'm adding the first four terms, I have to do 1/2 plus 1/4 plus 1/8 plus 1/16. Again, I know the sum of the first three of them is going to be 7/8. So now I'm going to find the sum of 7/8 and 1/16. So that's going to be 15/16. I'm hoping that you can see the pattern, that the numerator is one less than the denominator. So when I'm finding the sum of the first five terms, I have 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32. Again, the sum of the first four terms is 15/16. So if I add 15/16 to 1/32, that's going to be 31/32. So now let's graph these values in our coordinate plane. So the sum of the first term is going to be 1/2. So it's going to be right here. Then the next one, the sum of the first two terms is 0.75. So 0.75 is approximately here. Then the next one is 7/8. 7/8 as a decimal is 0.875. So 0.8, 0.9, 0.875 is approximately here. The next one is 15/16. 15 divided by 16 is 0.9375. So if I'm adding up four terms, I get 0.9375. And 31/32 is the last one. So if I find that is 0.96875, so that's going to be 0.96875. And if I'm looking at this graph, I can see that the sum is approaching to 1. So I can draw the conclusion is as n increases, the sum of the infinite series approaches 1. Please work on your first monitoring progress problem before you move on to the next slide. So, looking at the partial sums of infinite geometric series, we can see that the sum would approach to a number. However, there are some criteria. The sum of an infinite geometric series can be found by dividing the first term, which is a sub 1, by 1 subtract the common ratio. It has to be true that the absolute value of the common ratio has to be less than 1. In other words, the common ratio has to be between -1 and 1. It cannot equal 0, obviously. If the common ratio is greater than, the absolute value of common ratio is greater than or equal to 1, then the series has no sum. So in this problem, we are going to find the sum of infinite geometric series if the sum exists. So in the first case, in the first scenario, we are given a sigma notation. We know that the first term is going to be equal to 3, and the common ratio is going to be 0.7. Since the common ratio is between -1 and 1, and it does not equal 0, this particular series will have a sum. So the sum will be found by a1 divided by 1 minus r. So the sum will equal to the first term, which is 3, divided by 1 minus 0.7. So the sum will be 3 divided by 0.3. So finally the sum is going to equal to 10. Now let's look at our second sequence or series. In the second series, our first term is going to be 1, and then the common ratio is going to be 1 times 3, 3 times 3, so the common ratio is going to be 3. So it clearly shows that the common ratio is not between -1 and 1. Therefore, this particular series has no sum. And then let's look at our last problem. Here we have the first term is equal to 1, and the common ratio is going to be -3/4. So now we can find the sum. So the sum is going to be the first term, which is 1 divided by 1 minus -3/4. So the sum is going to be 1 divided by 1 plus 3/4. So the sum is going to be 1 divided by 7/4. And when we are dividing a whole number by a fraction, we multiply by the reciprocal. So finally the sum is going to equal to 4/7. This is a real-life word problem. It says a pendulum that is released to swing freely travels 18 inches on the first swing. On each successive swing, the pendulum travels 80% of the distance of the previous swing. What is the total distance of the pendulum swings? So we are going to again look at this infinite geometric series. If I look at what my first term would be, my first term is going to be 18. If I look at my common ratio is going to be 0.8. It's clear that 0.8 is going to be, that's 80% as a decimal. So 0.8 is between 1 and -1, and it does not equal 0. So we can find our sum as the first term divided by 1 minus the common ratio. So the sum is going to be 18 divided by 1 minus 0.8. So the sum is going to be 18 divided by 0.2. So finally the sum is going to equal to 90 inches. We can use infinite geometric series also to rewrite a repeating decimal as a fraction. So let's go ahead and look at 0.24, 24, 24, and so on. So I am going to rewrite this as a sequence. So I'm going to say 0.24 and then plus 0.24 times 1/100 plus 0.24 times 1/100 to the second place, and plus 0.24 times 1/100 to the third exponent, and so on. So we can clearly see that our first term is going to be 0.24. This is going to be our first term, and our common ratio is going to be 1/100. So if I look at this now, I'm going to have the sum, which is 0.24 divided by 1, take away 1/100. So the sum is going to be 0.24 divided by 1 subtract 100. So again, the sum is going to be 0.24 divided by 0.99. So now if I reduce the fraction, the sum is going to be 0.08 divided by 0.33. And if I multiply the numerator and the denominator by 100, the sum is going to equal to 8 divided by 33. Now please punch this in your calculator to see if you get the actual 0.242424 and ongoing decimal. On the next page you will have some monitoring progress problems. So again, finish those before you look at the next slide. Thank you for watching the lesson, and I'll see you on lesson 7.5.